All right, in this video, we're going to talk about how do you simplify radicals. Well, it's not that radically difficult. We're just going to break them apart and let's see how we can do that. Let's consider this situation. We have two radicals and they're butted up against each other, which means we're multiplying them. Under one radical, the radicand is A, and under the other radical, the radicand is B. What that means is I can combine those into a single radical where A times B is the radicand. That's handy. And it's especially handy to go either direction. We will often go from something that looks like this, where the product is in one radical, to this where we separate them. Okay. And similarly, we're going to say that if you've got the square root of A divided by the square root of B, that's the same as the square root of A divided by B. That's handy as well. Okay, so what does it mean to simplify a radical expression? Well, that means that we will have no common bases within the expression. That means I can't have an x in the numerator and an x in the denominator. You're going to have one variable x to raise to some power. Okay. Another thing that you're not going to see are factors that are perfect squares. Okay, so we'll see what we can do with that as we look at some examples. Now, one thing that we want to watch out for is we want our outcome when we simplify radicals. If anything comes out of the radical, we assume it to be positive. So if we end up with a variable that comes out of the radical, we will use absolute value notation around the variable, provided it is an odd powered variable. Okay. That's because we know we want it to represent something positive. And if we just look at variable x, x could represent something positive or negative. So once I put absolute value bars around the x, we know it represents something positive. They're not necessarily on even powered variables because let's say we have x squared. If x represents something positive and I square it, I get something positive out. If x represents something negative and I square it, I also get something positive out. So you see that I don't need those absolute value bars when I have an even powered variable. Okay, so let's give this a shot. When we are looking at simplifying something like this, the square root of 108, we want to break this into two radicals. All right, one of those radicals is going to have a perfect square factor, and this second radical will be all the leftover, whatever is left over in terms of the factors. Now we want the largest perfect square factor that we can find that goes evenly into 108. Now, it might be helpful for us to take a second and remind ourselves what are the first few perfect square values. And let's just name them up to 100. Well, of course, 1 times 1. That's not going to be that helpful here. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, of course, is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64, and 9 times 9 is 81, and of course 10 times 10 is 100. Just remembering that these are the first 10 perfect squares is going to be helpful. And of course you can go higher if need be. Now we want to see if one of these values in this list is a perfect square factor of 108. Now, of course, we want the largest perfect square factor of 108. And the way you quickly find the largest is you think about what is half of 108, and we work up the list from that value. So we know that half of 108 is 54, and 54 is right here, right? So we know it's not going to be anything down here. So we're going to work back up this way. Check 49. Does 49 go evenly into 108? It does not. But 36 does, right? 36 goes into 108 how many times? If you answered 3, you'd be absolutely right. Okay, perfect. Notice that this first radical represents the perfect square factor, and we do that because we're going to take it out of the radical. Since it's a perfect square, we can simplify the square root of 36 to just be 6, and then we would leave that leftover alone. So the square root of 108 is the same as 6 square root of 3. Let's take a look at the next one. We have the square root of 6x multiplied by the square root of 12x. Well, there's not a whole lot I can do with these individually. I could take a radical 4 out of that square root of 12, but let's see what happens when I combine them. This is the same as 6 times 12 is 72, x times x is x squared. Okay. All right, so now let's think about two radicals. What is the largest perfect square factor of 72? Using that rule, take half of 72, and what do you get? Well, you get 36. That's on our list. Well, that's good. So 36 times 2, and then think about x squared. X squared itself is a perfect square, so we're going to put it right inside that perfect square radical. All right, so now let's take a second and take the square root of 36x squared. This will be 6x, and this will be the square root of 2. But remember, when you have a result that comes out of a radical that's a variable, that's an odd power, we're going to add those absolute value notations right there. Beautiful. All right, the last one we're going to work on together. We're going to look at the square root of 150x to the fourth divided by the square root of 2x. Okay, let's actually put those two things together under one radical. We have 150x to the fourth divided by 2x. Now let's take that fraction and simplify it. 150 divided by 2, that's the same as 75. X to the fourth divided by x, that's going to be x cubed. Okay, already we're making good progress. All right, so now let's think about those two radicals, a perfect square and all the leftovers. Let's think about what's half of 75. Well, that's 37 and a half. And so we're going to work back up the list from there. 36 obviously is not going to go evenly into 75. Go backwards and we'll hit 25, and that's our answer. 25 goes into 75 3 times. And then let's look at that x cubed. X cubed is not a perfect square, so we want the largest possible perfect square. That is a factor of x cubed. That's going to go into this radical. That's going to be x squared. And then the leftover will be just x. All right, let's take everything out of that first radical. This is going to be 5x, square root of 3x. And what do you think we need to add there? Hopefully you recognize that we're going to need absolute value bars around that x variable. Hope this helps you simplify some radicals, and I'll see you next time.